Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about projections of the planes. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we are required to evaluate the projections of the oblique planes which is inclined to the horizontal plane as well as with respect to the vertical plane. So here we have been provided with a rhombus in which the major and minor diagonal dimensions they have been provided to us. So in the case of this rhombus, the major diagonal measures 40 millimeter while the minor diagonal of this rhombus measures 30 millimeter. Now the lamina, it is resting on one of its corners onto the horizontal plane and the lamina is inclined to HP in such a way that its major diagonal appears as a minor diagonal of 22 millimeter after the inclination of this rhombus with respect to the horizontal plane. Now first of all, we will see that since the first inclination of this rhombus lamina, it happens to be with respect to the horizontal plane, therefore to begin with, we are going to assume that this rhombus, it happens to be lying onto the horizontal plane. Now, since this rhombus, we are going to assume that it is going to lie onto the horizontal plane. So, to begin with, we are going to start with the construction of true shape of this particular rhombus onto the HP, that is onto the top view projections. So, we are going to draw the true shape of this rhombus below the XY reference line. Now regarding the orientation of this rhombus shaped lamina onto the horizontal plane, so there are two orientations which we can have into this particular case, because in either case whether we orient the rhombus in this orientation or we orient the rhombus in this orientation, once we tilt this rhombus shaped lamina with respect to horizontal plane, in either case it will be resting onto one of its corners onto the ground. So we can have the rhombus resting onto the ground onto either this end or onto this end. But we have been provided with the situation that whenever we tilt this rhombus lamina with respect to the horizontal plane, its major diagonal, it is going to get foreshortened or reduced in such a way that in the top view the foreshortened length of this major diagonal, which happens to be 40 millimeter, it is going to get reduced to a minor diagonal which is going to measure 22 millimeter. So if we are going to choose this orientation and we are going to tilt the lamina with respect to the horizontal plane, we will find that the major diagonal will remain unaltered while the minor diagonal of the lamina will be getting foreshortened projection onto the horizontal plane. So that is why this orientation of the lamina is incorrect. Whereas in this case, we can see that this is the major diagonal which measures 40 millimeter. This is the minor diagonal which is going to measure 30 millimeter. Now, once we tilt this lamina with respect to horizontal plane, so the minor diagonal of 30 millimeter, this will be unaltered onto the plan view because this is still parallel to the horizontal plane. Whereas because of the inclination of this lamina with respect to the horizontal plane, we are going to witness the foreshortening or reduction of the major diagonal of this particular lamina, and we are going to get the reduction of this major diagonal in such a way that after the inclination of this lamina with respect to HP, this major diagonal gets reduced to a minor diagonal measuring length is equal to 22 millimeter. So this way, this orientation is found to be the appropriate orientation of the lamina which is going to rest onto the ground to begin with. Now we are required to draw the orthographic projections of this lamina when this original minor diagonal of 30 millimeter, that is even after the inclination of this particular lamina with respect to the horizontal plane, this minor diagonal will still be equal to 30 millimeter in the top view. So this original minor diagonal, which is measuring 30 millimeter, it is further inclined at an angle of 45 degree with respect to the vertical plane. So that is why orthographic projections of an oblique lamina which happens to be inclined to both HP and VP need to be obtained in this particular case. So let us proceed with the construction of the orthographic projections of this oblique lamina. Now, as we have discussed, since the first angle of inclination of the surface of the lamina happens to be with respect to the horizontal plane, so onto the horizontal plane, that is below the XY reference line, in the top view we are going to obtain the true shape of the rhombus shaped lamina over here. So this is the rhombus shaped lamina, in which this is going to be our major diagonal and this is going to be our minor diagonal. So this is the true shape of this lamina that we are going to have. So here we have to draw this rhombus in such a way that the minor diagonal is going to measure 30 millimeter, while the length of the major diagonal, that is equal to AC, it is equal to 40 millimeter. So the minor diagonal is the diagonal BD as it appears to us in the top view, and the major diagonal happens to be AC, which is measuring 40 millimeter. So now we have shown both the minor diagonal as well as the major diagonal. Now, having located this rhombus lamina into the top view projection, now we have to obtain the front view projections of this particular lamina. So the true shape of this lamina has been drawn into the top view projections on the horizontal plane. Now we know that since one of the ends of the lamina or the corners of the lamina, it is resting onto the ground. So to begin with, we are going to assume that this lamina will be resting on the horizontal plane. So in the front view, as we are going to look at this particular lamina from this side, point A will be appearing onto the XY reference line as A dash, B dash and D dash points corresponding to the minor diagonal, they will be coinciding with each other in the front view on the XY line, and we are going to obtain the points B dash and D dash over here. And finally, when we are going to look at point C, so we see that the corner C will be appearing as point C dash onto the XY reference line. So having obtained the front view corresponding to all the four corners of this rhombus shaped lamina, now we can join A dash, B dash, C dash and D dash, and we will be getting edge view representation of this lamina onto the horizontal plane or onto the XY reference line. So now edge view has been obtained in the front view projections. True shape projections have been obtained onto the top view projections over here. Now, usually we are provided with the inclination of the surface of the lamina with respect to the horizontal plane, and correspondingly we are required to evaluate the reduction in the true length of the major diagonal, that is the diagonal AC over here. But in this case it is the vice versa. We are not provided with the angle of inclination of the surface of the lamina with respect to the ground. Rather, what we have been provided with, we have been provided with the foreshortened length of the longer diagonal of this rhombus, which is AC. So now we have to draw a new rhombus in which this longer edge, that is the longer diagonal, it is being represented as 22 millimeter instead of 40 millimeter, which was the true length. So the apparent length of this particular major diagonal is now 22 millimeter, so that this distance will be 11 millimeter and this distance will also be 11 millimeter in the top view. So now we have to draw the projections of the top view first, and correspondingly in the front view orientation we will be able to obtain the angle of inclination of the surface of the lamina with respect to horizontal plane or with respect to the ground. Now we see that as we are going to incline this surface of the lamina with respect to the horizontal plane, so there will be foreshortening of this longer diagonal AC, whereas the shorter diagonal BD of this rhombus, it will remain unaltered as 30 millimeter. Why this will be unaltered? Because this minor diagonal will still be parallel to the horizontal plane. Now since this minor diagonal, even after the inclined orientation of the surface of the lamina with respect to HP, it is still parallel to the horizontal plane. So in the top view projections, we are going to obtain the minor diagonal as 30 millimeter over here. So we can see this distance will be retained as 30 millimeter. So the projectors we have drawn through points B and D from the previous view. So they will provide us with the length of the minor diagonal of this rhombus as unaltered as 30 millimeter. So this length will be 30 millimeter. Now we know that after the inclination of this lamina with respect to the horizontal plane, the major diagonal AC will now be projected as a minor diagonal having length is equal to 22 millimeter. So this distance we have to draw as 11 millimeter. This distance we have to mark as 11 millimeter. Okay. So this is 15. This is 15. So the distance between B1 and D1 points, this will be 30 millimeter. Now the distance between A1 and C1, this will be equal to 22 millimeter. So this earlier major diagonal now has been reduced to a minor diagonal in the new apparent length top view projections which have been obtained over here. So now we have got the original minor diagonal which is equal to 30 millimeter and the new major diagonal which is appearing as a minor diagonal over here as A1 C1 is equal to 22 millimeter. So this length between B1 and D1 happens to be the true length, and this length or the distance between A1 and C1, it happens to be the apparent length projection over here. So this diagonal is represented as a apparent length diagonal, whereas the B1 D1 diagonal, it is represented as a true length diagonal projection over here in the top view projection. Now having obtained this apparent length of 22 millimeter corresponding to the original major diagonal, now we have to orient or incline this diagonal in such a way that we should be able to obtain the reduction from 40 millimeter to 22 millimeter in the top view projection over here. So if this major diagonal, that is if this original major diagonal A1 C1 happens to be parallel to the vertical plane, so in the front view we should be able to obtain the true length of this projection A1 C1 in the front view projections over here. So what we are going to do, through this point A over here, that is A1 dash, so this edge view will be constructed or this will be reoriented at such an angle that these 2 points, that is A dash point and C dash points, they will be located alongside these two vertical projector lines which we have to draw from A1 and C1 points over here. So once we draw two vertical projector lines from A1 and C1, so we have to mark a distance of 40 millimeter length starting from the point A1 dash over here. So from A1 dash, we have just translated or rotated this true length projection which we had obtained with respect to the major diagonal AC of this particular rhombus over here. So this true length of the major diagonal A dash C dash has been rotated through an angle theta in such a way that point A1 dash will be lying onto the ground corresponding to the vertical projector drawn through the point A1, and C1 dash will be located or obtained onto the end projector which has been drawn through the point C1 over here. So once we are able to obtain this distance of A1 dash and C1 dash is equal to 40 millimeter, we will be able to locate the angle of orientation or inclination of this particular true length of the major diagonal with respect to the horizontal plane. So this way we can also locate the points B1 dash and D1 dash. How much is the distance? It is this distance is equal to 20 millimeter. So this is also 20. This distance is also 20. So now we have been able to obtain the inclination of the surface or the edge view of the lamina with respect to horizontal plane inclined at an angle of theta over here. So now being able to obtain the front view projections and the top view projections corresponding to the inclined lamina, that is the rhombus, which is going to rest onto one of its corners onto the horizontal plane, and this inclination has been obtained in such a way that the original minor diagonal of 40 millimeter gets reduced to 22 millimeter in the plan projection view, which has been obtained over here. Now we have also been provided with further information that the original minor diagonal, which is measuring 30 millimeter, that is B1 D1. So into this plan projection view we have got one true length B1 D1 diagonal. Again we have got an apparent length of the original major diagonal A1 C1, which is appearing as an apparent length measuring 22 millimeter. So now this original minor diameter measuring 30 millimeter B1 D1. So this is further inclined with respect to vertical plane at an angle of 45 degree. So this plan projection view which we have obtained corresponding to A1, B1, C1, D1. So this has to be rotated or translated with respect to vertical plane at an angle of 45 degree. So this orientation we have obtained with respect to vertical plane at an angle of 45 degree. Now onto this orientation line we are required to locate our original true length of the minor diagonal, that is B1 D1. So these 4 points we need to transfer over here in such a way that B1 D1 will be represented as B2 D2 points onto this orientation projection line, which has been drawn at an angle of 45 degree. So please check the intersection of the diagonals. It is occurring at this position. So we have obtained the intersection point to begin with, because this figure A1 B1 C1 D1, it has to be rotated over here such that B1 and D1 points, they will be located as B2 and D2 points onto this orientation line inclined at an angle of 45 degree with respect to vertical plane. So now this center point has been obtained. After you obtain the center point, I know this distance of this intersection point of the diagonals and points D1 and B1, it happens to be 15 millimeter. So these two distances I have marked as 15 each, whereas distance from the center or the intersection point of the points A1 and C1, this happens to be 11 and 11. So this is 11, this is 11, this is 15 and this is 15. So 15 and 15 I have marked, 11 millimeter and 11 millimeter in the perpendicular direction also I have marked. So all the 4 points, they have been located in such a way that the original minor diagonal of 30 millimeter B1 D1, it will be located over here. So now we have reconstructed this figure in such a way that the true length of the minor diagonal has been located onto this orientation line. Now we can mark the points A2, B2, C2 and D2 onto the plan projection view. So these are plan projections corresponding to the oblique lamina, which is inclined with respect to HP and inclined with respect to VP. Now in the final stage we are required to evaluate corresponding front view projections A2 dash, B2 dash, C2 dash and D2 dash. So how that can be done? From all these 4 points of the plan projection which have been obtained over here, A2, B2, C2 and D2. So we are going to draw 4 vertical projector lines moving into the upward direction in such a way that they should be intersecting with the corresponding horizontal lines which have been drawn from the corresponding front view projection viewpoints A1 dash, B1 dash, C1 dash and D1 dash. So let us start. So here we have A2 point. So from A2 point we are going to draw a vertical projector upwards and extend this upwards till it is going to intersect with horizontal line which is drawn through the point A1 dash of the elevation. So A1 dash horizontal projector will lie here. So this intersection of the vertical projector drawn through A2 and the horizontal projector drawn through A1 dash, it will provide us with A2 dash. Similarly, B point. So from B2, draw a vertical projector. From B1 dash, draw a horizontal projector. Obtain the intersection of the two projectors over here. So this intersection provides us with the front view of the point B dash. Similarly, for obtaining C2 dash, draw a vertical projector through the point C2 and extend it till the point it intersects with the horizontal projection line which is drawn through the point C1 dash. So this intersection provides us with the location of the corner C2 dash in the front view corresponding to the point C. Finally, the point D2 dash has to be located. So draw a vertical projector through D2 and extend it till it intersects with the horizontal projector line which is drawn through the point D1 dash. So this way A2 dash, B2 dash, C2 dash and D2 dash points, they have been located in the front view projections. Now once you join A2 dash, B2 dash, C2 dash and D2 dash, so we are able to obtain the orthographic front view projections as well as the top view projections of an oblique lamina in which the surface of the lamina, it is inclined with respect to the horizontal plane at an angle theta, and the original minor diagonal BD, it happens to be inclined with respect to the vertical plane at an angle of 45 degree. So this is all for today. So I hope that through this discussion you would have understood about the procedure to evaluate the orthographic projections of an oblique rhombus shaped lamina which is inclined to both the horizontal plane and with respect to the vertical plane. So we will be continuing with further discussion regarding few more illustrative cases of projections of the planes in the coming lectures. Thank you very much. Thanks a lot.